Right, first of all, welcome. We'll be having two sessions. The first will be about an hour long, and then we'll break for pizza. Both sessions are going to be by Martin. First is on machine learning, and the second is on serverless. If you need a toilet, then just out that door and to the left. If there's a fire, which there hopefully won't be, then the fire exit is in that far corner there. And over to you.
Awesome, that's good. Hello everyone, how are you doing? So, have you been on an offsite today, everyone, or just some people?
Just some people.
Just some people, okay. So my name's Martin Beebe, I work for AWS. I'm a software developer. I've been a software developer for 20 years now. I started developing when I was 16 years old in my bedroom in a little place not far from here called Corby. Anyone know Corby? Yeah. It's got a reputation. So I didn't get involved in all the games. What I did was write websites, and it's a nice little. I started building little hacks and so forth, and bits and pieces from my bedroom, and I happened upon an API that HMV, the record store, that they had, and what you could do with it is just change a couple of the parameters, and you could call it and send text messages for free. And so at the time when text messages were 30 pence a time, I wrote a little website which allowed people to send free text messages to each other. That's my first ever website. Completely, obviously, I didn't tell HMV that was just in their API. A couple of people in my school used it, then a couple of people in my school used it, and then a couple of people in my other schools started using it, because I put a little thing at the bottom of the text message which says, sent from thebeebs.co.uk. And I got that domain free with my ASP as well, which was good. And then more and more people started using it, and then I got stopped once in a nightclub by a person who said, "Oh, you're the Beebs. I use your text messaging service." And then, about 4 weeks later, I got a call from HMV with a cease and desist, because I'd been sending something like 1% of all the UK's text messages through this. And it was at that point I realised the power of the web and software development. In fact, you could do that from your own bedroom. They offered me a job, actually, HMV, which I turned down. But it gave me the sort of confidence that I could actually be a developer and be a software developer. And then I worked in some various e-commerce companies. I worked at Misco, which is just in Wellingborough. They're a big .NET workshop and stuff. Anyone worked at Misco? There's always a chance. Yeah, one person, okay. Worked at Misco for a little while as a software developer. If you did, then sorry about that code that I wrote. It was on VB. And then I sort of progressed and so forth, and then became an MVC.NET application developer. I worked for Microsoft for 8 years. I had a stint at Oracle for a little while, and now I'm over at AWS. So I had a little tour of cloud providers, and what I found in all of my sort of development years and all the stuff that I've done over the years, so I say 20 years now, I started when I was 16. I'll do the maths, that makes me 21 years old. That I always quite like to push or find new ways of doing things. Like, I'm definitely the sort of person who goes to lots of meetups. I go to read lots of blogs, I read lots of community stuff. So I'm always quite interested in what other people are doing and how they're doing it. And machine learning for me is an area of exploration, something I've explored quite a lot over the last 4 or 5 years. And I kind of wanted to show you over the next hour some of the stuff that AWS do with machine learning, and the kinds of service that any developer, literally any developer, can come and pick up and use. And we're going to start with the really simple stuff, with what they've got on offer with machine learning, and then we're going to look at some of the more complicated services, which are actually not that complicated, but they sometimes appear to be complicated for an average developer. So really this is just like, well, what does machine learning mean for someone which is a non-specialist, not a data scientist, just someone which is capable of writing an API to call HMV's API and take advantage of that. If you're capable of doing that, then you can do machine learning. And so, there's a mission inside the machine learning team at AWS. Well, there's a great mission to sort of enable customers to transform their business, and that's what AWS attempt to do with everything that they do. All the services that we build are intended to try and make life easier for customers to build better products. And at AWS, we're trying to make developers' lives, architects' lives easier, and they're able to do more, scale more, have more impact. And really, it boils down in machine learning to put machine learning in the hands of every developer. And it's not just an AWS thing, this has happened across the industry as well, where machine learning has gone from being this really complex black box, which was the privy of data scientists and specialist developers, and it's opened up now to enable pretty much anyone to start doing really interesting things and start enabling certain features in their applications and do things that perhaps would have been much, much more complicated years ago. A lot of the, I guess the stuff that we do is based upon feedback that we get from customers. So a lot of people will look at AWS's service, the roster of services, all the different products, and think, well, you've got a lot there, there's a lot going on. What often happens is if we have enough customers telling us something that they need to do, especially in say, something like ML, then we'll try and build services around that to do the heavy lifting, to enable them to kind of grow and do certain things. And most of the services that you see here, 90% of the roadmap, the ML roadmap, is driven by customers saying, wouldn't it be great if we could do this? And we go, well, we actually could enable that. We could help you with that with services that we offer in our cloud. We've got quite a strong pace of innovation at AWS. There's lots of services being added all the time. There's been over 200 new ML launches in the last year. So that's different services, different features, different capabilities that have been enabled in the last year. That's up to 2008. So it's probably even more than that. For November 2008, it's probably even more now. There's a wide range of offerings in machine learning. There's stuff which is just APIs that you can call. I guess that's where ML for every developer started. The idea that you have an API which does some clever stuff, you send an image or you send some data to it, and it can give you a result or tell you something about that image or that data. We've moved now on to sort of things where we provide not only like inputs like images or some data, we actually provide like historical data and then give you ways of analysing that stuff with machine learning as well. And then we've also gone to the depths of actually providing you like the base level services. If you want to go and build your own machine learning services, we're able to do that as well. So if you're actually a data specialist data scientist, then we can start using our infrastructure to start building machine learning. We support lots of different frameworks. There's lots of different ways to skin a cat with machine learning in AWS. You can take pretty much any machine learning framework is supported by AWS. And you can use the stuff that we provide, you can use stuff that other people provide. And you'll find that many of the sort of leading machine learning workloads happen on AWS in some form or another. So, and things like, so as with, everyone's going to say this of course, but it's a really important part of building machine learning or thinking about machine learning is how do we secure it, how do we monitor it in production, and those sorts of things we've been thinking about really heavily. There's a ton of customers which use our machine learning services. I'll just call out two, which mean something to me, I guess. One is, the first one, so I've been trying to play the guitar since I was 16 years old, and I've struggled for a long time. I've had private lessons, I'm okay, I was in bands, they were all rubbish, but I can sort of play. And about last year I went to Fender Play, and there's this sort of like new movement in learning guitar, which has happened, and there's a couple of companies which are offering this service, but Fender, the manufacturer of the guitars obviously, they've come up with a new service called Fender Play, which is something I'm a subscriber to. And what it allows you to do is log on and follow like a learning plan, a specific curriculum, sort of like studio 4K shoots of instructors teaching you how to use the guitar. And it's really good. Like if you're ever interested in learning guitar, Fender Play is an incredible resource to be able to do it. It's much easier than say like using just YouTube videos or finding like different curriculum on tab.com or something like that. And it provides things like the instructor levels and different chapters. There's different learning plans and stuff. It's all built on AWS. A lot of it's built using serverless technology, and they're doing tons of stuff with not only video processing. They're producing terabytes and terabytes of video every week from their content that they're producing, but they're also doing things like machine learning to do transcoding and translation. So they'll be transcribing the videos from audio, the audio sounds which come in there. They'll be transcribing them to text for subtitling and captioning, closed captioning and that sort of thing. And they're also doing machine translation so that they can have broader global reach with their videos as well. And so there's lots of experimentation which they've been doing just there with their videos, making sure that they're enabled through machine learning. They also follow or look at the data and the way that people are using the application. For Fender, it's a really important business problem because they've got to think about if someone picks up a guitar, and I think if they stay with it for longer than 6 months, and they sort of get over that initial hump of owning a guitar, they're likely to buy a further 8 guitars in their life. Whereas if they don't get over that initial hump, you can understand that guitar just sits under the bed. So for them, it's really important for them to get people over that hump. So they look at the data and find the people which have been successful, why they're successful, where they're coming from, why are they using the site, how are they using the site, what platforms are they using the site on, and then they're trying to use that to try and encourage other people to be successful with guitar as well. So looking at the data of the platform and really understanding what their users are doing with it and how they're getting successful, and so that they can make better content and make it more successful. And they're also using machine learning in their manufacturing process of their guitars as well. They're using SageMaker, which is something which we'll look at later, to help them with wood matching for their guitars, so matching the right kinds of woods in the build of their guitars. So they're using it all across their product portfolio. But this is one product that I just use, which so happens to be using machine learning on AWS. Another example is Sky News. If you were looking at the royal wedding, they had this whole parade of people, posh people, walking into a building. And it's quite difficult for everyone to know who each of those posh people are, or who those celebrities are, and so forth. So they built a machine learning algorithm which ingested all the video and then was able to find out or recognize the celebrities in the images and then overlay it with information about the biographies for their viewers. So the viewers could see, okay, that's Earl Spencer, that's Countess Spencer. I wouldn't have been able to pick Countess Spencer necessarily out there. I wouldn't be able to pick Earl Spencer because he travels on the same train that I do on Northampton. I actually spoke to him for an hour on a train from London to Northampton. And I sort of half recognised him. Thought I knew he spoke. I sort of didn't think he was famous. I just go, I sort of know you. For the whole hour, I was convinced he was now a geography teacher. And I was thinking, maybe he's a substitute. He's a bit too posh for a substitute. Then I found out right at the end it was Earl Spencer. But yeah, it's quite a nice guy. He would make a good geography teacher, I reckon, as well. But it was showing you all the different rivals, it was recognising celebrities, all doing from a video stream. And the way you actually go and build something like that is, we've got lots of services which allow you to do the ingestion of video real time, and then analyse the different frames in that video. And they're using a partner product as well, but they're also using Amazon Recognition, which has a celebrity feature which you can send images or video to it, and it can recognise the celebrities in the video. And then they're ultimately putting all that information, combining with bios from administrators, doing moderation on the content to make sure that it's of the right type, and then they're going to ultimately format it or give it to the viewer in a UI which looks a little bit like that. But to get there, they've had to use thousands of different services from AWS. The transcoding, the video, the content delivery networks. There's tons and tons of different services that they've pieced together to produce an experience. And that's kind of the backbone of that experience is machine learning. And not long ago, to build something like that, you would have to have been a machine learning expert to be able to achieve this capability. To do facial recognition, then recognize the actual people, to do it on video as well. To do it in real time on video, it's really complicated stuff. But none of the people which worked on this, apart from maybe the partner, were specialists in machine learning. And I think that's sort of the kind of product that people are building nowadays. So we have this layer of AI services. If you think about the different capabilities of AWS and what we offer, we have AI services. So I'll show a few of these to give you an example of what I mean by AI services. Vision services, speech services, language services, chatbot services, forecasting, and APIs, which you can then call from your applications. And I'll build one of these. I'll show you how you build one of these on stage in a moment. And then we have different frameworks, and of course the infrastructure which underpins it all. Most of the infrastructure required to do machine learning, specifically the training portion of machine learning, is really GPU intensive. So we have different kinds of machines or images or instances which are capable of have like GPUs on them. I remember speaking to a boss of mine at another cloud company, trying to explain to him why GPUs were important. And he was like, but every machine's got a GPU. Not realizing, obviously in the cloud, there aren't any monitors on those machines, so they don't have GPUs by default. And so explaining to him that, they're really different, and you can't just use, you can use machines with just GPU, but that it's important to have GPUs or fields programmable gate arrays if you want to do machine learning at any kind of speed. So we have lots of different ways or different things on our platform which allow us to do machine learning. So let's look first at some of the AI services. So these are like the low-hanging fruit. If you wanted to add some AI spice to an application, there's tons of stuff that you could do with these sorts of things. There's a couple of new ones which are interesting. Most of the AI services up until about 2 or 3 years ago were kind of, we train a model, we put an API up, and then you would send a small piece of data to that API, an image, a piece of text, and we'd give you a response. But recently, we've been starting to generate, or cloud companies have been providing these models which are kind of, you provide us some historical data, and then we'll provide you with an API. You don't need to know anything about ML, just provide us the data. We'll provide you with an API specifically for you that you can call, and then it will be able to make predictions and do intelligent stuff based upon the domain data that you provided. Amazon Forecast is a good example of that. It's a way of allowing you to forecast. It's a relatively good name for it. It allows you to forecast events based upon historical data. So, let me just. So you provide the hot historical data, sales, inventory, pricing, related data like weather, competitive promotions, etc. All the different stuff which the data which makes up your market. You load the data, and Amazon Forecast will identify the features, select the algorithms, select the hyperparameters, train the models, optimize the models, deploy a host model for you, and give you an API at the end which you can then call. And you can then just ask for forecasting information based upon all that. So you might have built something like this in your previous careers. What AWS is now offering is this sort of service, effectively, where you provide your previous data and we can give you a forecasting model. We've got a number of partners which are currently customers which are using this already, and they're doing sorts of all kinds of stuff, forecasting, removing all of the different sort of the heavy lifting in building one of these sort of forecasting systems for yourself. In the same vein is a new service which got released at reInvent, our big conference in November last year, called Amazon Personalize. And this is possibly one of the, if you think about it, one of the oldest ML services on the web. It comes from Amazon's recommendation engine. So if you've ever bought anything from Amazon, there's a recommendation which is happening there under the hood, like if you bought this, then you might like this. That whole recommendation engine is now available from AWS. You provide information about the kind of products and so forth that you have, or the activity streams, things like views, sign-ups, conversion, etc., inventory, your products and whatnot, the demographics, and load that into our service. We'll do all the training of the models, we'll do all of the training of the deployment, and we'll give you an API which allows you to then make personalized recommendations. So, based upon historical sales data in your company, if they pick this, then they will likely be interested in this, X and Y. Now again, this is something which you might have built, or many people have built before, especially in e-commerce and retail. It's now being offered as a service, and it's exactly the same. The underpinning technology of this comes from Amazon.com and our recommendation engine. So now kind of like going on to a little bit more of a sort of, I guess, traditional ML stuff. If you've ever done OCR stuff, I've built OCR systems since like 2007, optical character recognition, so finding text in images. And it's relatively easy to do regular text in images and find pieces of text. You can get off-the-shelf libraries which will be able to do it for you. All the cloud providers now provide some form of OCR, optical character recognition. But if it comes to something like, I want to do forms, or I want optical character recognition on receipts, it can be a problem, because what you're doing is, effectively, you're not only looking at the characters on a document, you're actually looking at the relationship of the characters, where they fit, what box they fit in. Is there a form there? Is there a table there? What Textract is able to do is contextualize information. So you can think about it as OCR++. We not only do we recognize the characters, but we'll also be able to tell you if that's a form, and be able to say that there's a key value pair form. So that's name, and that's their name, that's their age, that's the age which they're filled out, and we can map those things together and provide it back to you as a developer as like a list or an array of key value pairs, rather than just here's a lump of text, you've got to figure out the connections between them. Likewise, we can figure out if there's tables in documents. and will provide you back like a list of the columns, or the table basically, in a JSON format. So it's basically OCR, but you can use it for things like extracting information from receipts, extracting information from forms, application forms, those sorts of things which are traditionally quite difficult with OCR. Again, this service doesn't require any ML experience. It's a pre-trained model. The example on AWS, if you go to the TechTrack console, it's in public preview at the moment, so you need to be whitelisted before you can use it. But I've used this service. You upload a document, and out comes some JSON, which describes the entire document and all the forms and all of the tables which are contained inside the document as well. Let's have a look at another. This is a more traditional one, I guess. But I'd call out how accurate and how interesting and stuff this particular service is in relation to competitors' versions of this. So if you, we can do image and video recognition. So basically we can take an image or a video and analyze the scene and tell you what's in it. So basically vision, giving your computer vision. And this is useful in loads of different contexts. I've built a couple of systems which have used similar technologies. I built one for Shrewsbury Museum. Shrewsbury Museum have an exhibit, or we built an exhibit for them, a smart exhibit, where people would go up in the museum, go in front of the exhibit. We would analyze the face of the person which was viewing the exhibit, and then depending on certain demographics, we'd give them different readouts of information. So if they were younger, we'd give them a slightly faster paced explanation of what they were looking at. So it was actually a big landscape, and in the younger people, when they came up to the screen and started looking at the screen, it would tell them things like, this is like a bit like an iPhone panorama, and it started explaining the picture in context of their age. And then if you were an older person, the machine started reading out an audio description, which is more of like a regular 4 explanation of the picture. It's a little bit haphazard, but the idea was, could we use demographics? Could we use where they'd been before in the museum, what museum exhibits they'd seen before, their journey around the museum, to give them more information? Okay, you actually looked at that last picture. It's actually relevant to this picture because it was done by the same artist, and tell you that stuff contextually. Or by allowing the computer to see you, understand a little bit about you, recognize you perhaps. Can we give a different experience in the museum? So we used a similar system to this. And so what you can do is upload images and videos. I was at Crafty Coders a few months ago, and Fletcher was giving a talk. And just to give you an idea of like the fidelity of this is a pretty low quality picture. You can see it's quite dark. Every box here, it's recognized a face. You'll notice that no one's facing forwards, no one's looking directly at the camera. It's recognizing a face, it's giving an age description of every single person in that room, even though none of them are looking at the camera. And the one I've sort of shown up on here, it's got Paul. He's 98.9% human, apparently. I don't know if Paul's here tonight. That's good. That's actually the confidence level that he's a human. He's a person, it recognises it's indoors. This is a room, there's furniture, chairs, there's a crowd, there's an audience. It recognises a lot about that image that you could do interesting things with. And if you just use your creativity, you can start thinking, well, I could basically you get this back as a JSON array, an array of all of the different people in the room, and we can loop through it. I can tell you how old all these different people are in respect to what it thinks at least. And if I clicked on that, it does say age ranges and so forth as well. This is a more classic face, I guess. Like straight on portrait, it's a little bit easier to, definitely 100% face, they've guaranteed that. I'm 99.7% of male. It's given my age range between 35 and 52, which is bang on. I'm not smiling, I appear to be calm, I'm not wearing glasses. And there's gradually more and more information. If you show more, there's loads of other features about the face that they can tell you. They can tell you the position of all of the different facial elements, like the eyebrows, the nostrils. If I want to overlay things on this person's face, I could absolutely do that. If I want to create Snapchat filters, where I was using this to overlay stuff over on the image, like a little moustache, or I'd probably like a little bit more hair, for example. I could quite easily do that. I'd turn down the grey on the sides of the hair, for example. We can also use this information to recognise if the person is the same or similar. Oh, cool. We're going to stop in 10 minutes, so I'm probably going to... Cool. You did throw me off when you said I had an hour. So. Sorry. It arrived. Yeah, cool, no worries.
We can start again afterwards.
No worries, cool. So I'll go through these bits and then we'll probably pick up the SageMaker a bit after the break and then get into servers. So you can pick up all of this stuff, you can find out all the different features of an image, and it's pretty cool in that sense. This does do, like, on this particular, I was just showing you the facial recognition. You can see how far away a face is. That's the actual image of the face that I have. And it's still able to tell me that it's 99% of this face, it appears to be male, the age range is 35 to 55 years, he's probably smiling, he appears to be a little sad, he's not wearing glasses. No offense, Paul. You'll see in this one, I also put another little filter on recognition, said, can you see any celebrities recognition? So it's just another way, when you do an API, you can set up the API to do certain different features. I've asked a celebrity request, so I've said, are there any celebrities in this image? Sadly, it's not picked up that I look an awful lot like Brad Pitt. Okay, I don't. But if I put another image of someone which is super famous, like Mike Myers, or maybe not even that famous anymore, but certainly in my book, the most famous person, I love Wayne's World, my favourite film. I know that's quite a sad thing to admit, but I don't care. He's picked up that that's Mike Myers, and it's got 100% match confidence that's Mike Myers. But it's quite good with celebrities which are a little bit more obscure. So last time I was here, Paul Fletcher was talking about Blizzard, and Blizzard Entertainment and all that sort of stuff. I don't know anything about Blizzard, but if I went to recognition and put this, which is one of the founders of Blizzard, it was able to recognise that that's Michael Marine. I don't recognise the second name, so I just mumble. It recognises him as 100% match confidence, so it will recognise all sorts of celebrities from all sorts of different worlds, being CEOs of companies and whatnot, which is useful in lots of different scenarios, specifically, I guess, for things like Sky News, where they want to recognise celebrities in a video, they could use recognition for that. A lot of people say that I look like this guy. This is Mark from Peep Show. You can, with the API of recognition, say whether or not two images or two people look similar. And I'm glad to confirm that with the power of that now, I can say that I am actually 26% similar to Mark from Peep Show. So, you know, it's good for sort of solving those sorts of 26.3% similarity. So you can use it to kind of recognise different images, or is that person the same person? Usually that would be used for like sign-ins. So is that the same person which presented a few moments ago? We used that feature in Shrewsbury Museum because we had a number of the exhibits had cameras on them and they were recording, and we were plotting people's navigation through the museum. And the way that we plotted the navigation was by recognising them once, and then at the next thing we'd compare their face with all the people which we captured that day, and say, is it the same person? So that we could plot which exhibits they went to. It was an interesting experiment to see if we could understand their movement across the museum, and also then play different audio descriptions depending on the route in the museum. So that's what we used that face recognition, similarity recognition for. So it's a state-of-the-art thing, but it's very low cost. These APIs cost very, very little to call. It's a service, so it's constantly improving. We're adding new features to it, new celebrities to the recognition. We're being able to recognise different facial landmarks all the time. We're able to work with very, very, very low quality face images that we have. We don't keep your data, we don't use your data, it's your data. We're not using those images to further benefit, say, the recognition service. It's serverless, you don't need to use any infrastructure, it's a server. You just call it, you don't have to worry about how it's scaled or anything like that, it's just an API for you. The next one I'll talk about is comprehend. And this is more of a text-based ML service, and it allows you to find like different relationships in text. So if we go on the Crafty Code's website, there is a what we are about section. If I take that text, software is complex stuff. This is something that's been appreciated and complex since the 70s. Blah, 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 blah. And I pass that through this service. It will look at the service and start to find entities in that text. So we can see two here. It's picked up 70s and West Midlands. It's recognised that West Midlands is a location and the 17s is a date. So we've started to be able to pick out stuff from our text. Now you might be using this in sort of chatbots. You might use this in as trying to understand contextually documents or information in applications. And it will tag entities in there. It will also highlight key phrases. in the document. So all of the responses are basically, it's APIs that you call, you get a response back in JSON to do something with. So these are the entities, so there's a date, 70s, and you can figure out from that exactly when the 70s is as well to an actual epoch date. Then it fills out the key phrases, what it thinks are key phrases, so software, complex stuff, so you kind of get some context about what text means using machine learning. It recognises the language that someone's using. That's an important one. In chatbots, I wrote chatbots. I worked for the London School of English. I wrote a chatbot about 4 years ago, and they wanted to detect if someone was speaking to them in English or Chinese or any other language for that matter. So they would someone would type into this chatbot, and the chatbot would then recognise what language that they were speaking and then respond to them in the same language. So that's what you might use the language recogniser for. So are they speaking English? Are they entering English text? Then you can look at sentiment, figure out something being negative or positive, and that's quite useful for understanding like reviews on websites and looking through reviews on websites and finding out if people are happy or unhappy. Doing flash trawls through content relationship management systems. We use it again in chatbots. We use sentiment to, if someone's getting frustrated with the experience, we can often switch out the chatbot and pass them over to an actual human to deal with their request, rather than them dealing with the chatbot. So sentiment is a really important other way of figuring out if someone's having a good or bad experience with an AI representative through a chatbot. And then the syntax as well. Every word is being classified in that sentence. It's to tell you what it is. Is it a noun, is it a verb, is it an adjective? To understand the relationship of that text. The other thing we're able to do is understand different age of the person from that piece of text. That they're a high school treasure, that's a profession. That they've got a medication called clonidine, it's a generic name. So all of that in a domain-specific setting we have specifically for healthcare. And I think this is the last one I'm going to talk about before we break for pizza, which is Amazon Polly. Amazon Polly allows you to take written text and convert it into spoken English. So Polly is really useful. Lots of companies are using it. We use it obviously for Alexa. So when Alexa speaks to you, sometimes she's using a voice actor, sometimes she's using Polly to speak to you. So it's a very lifelike human sort of sounding voice. So this is an example of it, which you can't hear because there's no audio, I guess.
No, we've never managed to figure that one out. It's a new system.
Oh. Well, then I just have to kind of do what it says.
You can do the voice.
This is Joanne female. Hello. I hope you're well. That's what it would say if you were doing it. It does sound very human-like. There's a British version in different languages. Hello, well. Again, you'll recognise the voices because they're used in Polly, but they're also used by like all kinds of phone systems. You will have definitely heard Polly speak to you in one of her many accents from all over the world. She can manage different languages, different countries, different accents. There's British Welsh, there's French. What I quite like to do is take the ones which are actually trained for different languages and then have them speak English. And they actually do sound like if you get the voice to speak English, it does sound like a French person's trying to speak English. It's really cool. They pronounce things French. It's really nice. Also, you can do things on it. Expletives, it will bleep out expletives. So for example, these aren't actually expletives, but I've bleeped them out anyway. So it says, why don't you go fudge off? Why don't you go fudge off? Would actually come on, why don't you beep off? You complete it up, beep, and yeah, you complete it up. That's what that will do by just using this language called XML. Instead of just providing text to the service, you can change the effect of the way it speaks and tell it a little bit more context about the voice. And you can do something like this as well when you get it to whisper certain phrases. So it would say this, I want to tell you a secret. And it would say that normally, and then it would say, I don't think Brexit is doing this on Amazon Lambda. Yikes. And so you can give the voice system a way of saying certain things in different sort of tones and different effects to make it more interesting. So if you're building skills for Alexa or anything really, like for example, we've used this Polly on our website, on our blogs. Polly will read our blogs to you. So if you go to any of the AWS blogs, you can press the play button and you can have it be read to you instead of reading it out loud. And if you want to do that yourself, you can call the service, or if you're using WordPress, we have a plugin for WordPress, which will automatically add that little play button to the top of your blogs on WordPress. Yep.
So would Polly be used for like Audible?
She could do, yeah, so she is. Actually, a lot of companies use it, you know, when they don't want to pay a voice actor to read a book, or the author isn't perhaps famous enough to have someone sit and read the whole book. Polly might read that, and you will find tracks on certain podcasts. There are quite a lot of spam podcasts as well, which is Polly, which can generate random content. I don't know why, but they do that. But yeah, lots of companies use it, and if you read through the use cases of Polly, it's really diverse. But it's basically anywhere where you've got the text and you just want a human-like voice to read it. And it's really human-like. I mean, it's not robotic at all. You can't hear that, obviously, because we don't have sound. But I promise you, it's very human-like. And then one of the other ones is translation. We obviously do translation. It's 20 different languages, and there's lots of different combinations you can do it. So this is my source language. It's actually using that language detection from the other API to figure out what language I'm speaking. Okay, it's French. J'aime jouer le foot. C'est in French I learn from Corby Education, which is I like to play football. I actually don't like to play football, but it's still the only phrase I know in French. I hate football, never mind. And transcribe is the other way around. Transcribe will, and this is really a shame you can't hear this as well. This is me doing my best version of, oops. Let's see if it plays out. But I'm at the moment saying, in West Philadelphia, born and raised, on the playground is where I spend most of my days. Chilling out, maxing, relaxing or cooling, shooting some people outside of the school. When a couple of guys, they were up to no good, started making trouble in my neighborhood. I got in one little fight and my mom got scared and said, "You're moving to your auntie and uncle to Bel Air." And it would come up with that. What this is a Java, it's actually a Java application calling an API, streaming the audio to a service which is doing real-time transcription. You'll see it changes constantly as to what it thinks it is. And that's because as it gets more real-time information about what you're next saying, it puts it into context, and it figures out actually probably meant this or that or that. And you'll see at the end when I said Bel Air, so that's quite domain specific, it's actually picked up as Isabel. And I tried Bel Air again, it said to Bell, and then I said never mind. But that's that kind of concept of the sort of thing you can build off the gate, just calling APIs. After pizza, I'll show you how you can build your own one of these for a specific domain model. Okay, have some pizza.
Right, so we'll have a short break for pizza. I'm really sorry, Domino's doesn't use AI, and last time they were really late, they were really early. So as a short break, we'll come back.
Actually, Domino's is one of our launch partners. They actually use forecasts, and they use lots of our services, but yes, they don't necessarily have the delivery on time. Right, okay, so I mentioned earlier AI services, stuff which is already built for you and that you can use. Well, there are ways of making your own models as well. Now, if you've ever done any machine learning before, you'll know, or perhaps heard of a thing called Jupyter Notebooks. Jupyter Notebooks is like a developer environment for data scientists. It's like an open source thing. You can install it yourself. You don't need to be using AWS necessarily to do this, but we've wrapped some of that Jupyter Notebook stuff up and provisioned it, or enabled you to provision it. So you can basically say, I want to create a notebook instance in your AWS account and SageMaker. And what that's going to do is provision an EC2 image, a virtual machine, an instance, which is going to have the GPUs which are going to be required, and the sort of software required to do some data sciencey work. It's going to install a thing called Jupyter Notebooks, which is it's a bit like a mix between an IDE and a document, in that you can document your data science model and how it's constructed. And it's probably easier just to show you than it is to speak about it. So what I did is I created a notebook instance inside of SageMaker. This is Amazon SageMaker instead of AWS. And once I've created that, it takes about 10 minutes. It's basically 5 minutes, sorry. Creates a EC2 instance, installs all the software that's required and provisions it for you, so that you can just then go and open up the Jupyter Notebook. And if I go into my Jupyter Notebook instance, what I'll have is a document which describes like my code. Here we go. So you might be confused to think this is a document because it looks a bit like a document, but I promise you this is an actual IDE. You can take this later if you want. It's on my GitHub. What I've done is actually, when you create an instance, you actually can say, clone this GitHub repo to my Jupyter Notebook as well, and that's what I've done here. And that's basically given me this document. And in this document, it describes how I start training my own image classifier. And an image classifier is a kind of machine learning model which will be able to recognize different types of images. So if you've seen like earlier, it classified like that someone was a human or recognized a human in an object. That was kind of a classifier which was doing that. It was recognizing as a shape, that's a human. And they can get really complex, like it doesn't have to just be a human, it could be like it recognizes a specific animal. We've built models which recognize different breeds of dog, for example, or different types of bird, or different kinds of drinks can, different kinds of chocolate bar, different kinds of people, different kinds of age ranges. They're all classifier problems, and this is how you would create your own classifier. So this document is interesting because it sort of describes what it's doing, and then you'll see these little sections here, which are actual bits of code, which you can then just press the play button and execute those pieces of code. And this is how data scientists will often work. It's a collaborative working environment, so they'll put together these bits of explanation, and then they'll run some code, you'll fill out some other parameters, run some code, and eventually train a model. Behind it, SageMaker does things like, we have some APIs in SageMaker which enable you to create different types of machine learning algorithms. We have tons of them, like literally hundreds and hundreds of algorithms that you could use. The skill really is knowing which algorithm to use and when. If you've got an image classifier problem, this, roughly what I've put together here, will help you solve that problem. But there's loads of other ways of solving different kinds of problems. If you want to analyze audio, or you want to do anything you want to do with ML, you could do in this scenario, or with this tooling. But let's just say we want to classify some images. So let's create some images. What I'm going to do is I'm going to create some images, labeled images of some things that I have around. So I have some markers here, and I have some drinks cans. Markers, drinks cans, and my face. So I'm going to have this recognizer be able to tell if it's a drinks can, if it's my face, or if it's a marker. So we're going to label some images to tell the computer what my face looks like, what a marker looks like. So what we're going to call this data set name. Does anyone? Face, markers, and drinks. Has anyone got a name for this data set? Anything?
Office crap.
Office crap, yeah.
Your face.
Thanks very much for that. I won't take it personally. Office crap, and we're going to label some faces first. Now, this little application I just wrote is just a React application. I've used a thing called Amplify. AWS Amplify is a really simple way of generating React applications. That's not important. What you will see is what it does is it just takes a feed from my webcam and it's uploading these to S3, Simple Storage Service, S3, SSS. I didn't know that until I joined AWS, that's why it's called S3. EC2, Elastic Container Cloud. Yeah, 2 C's, right? 3 S's. It's like, wow, Office crap, this is faces. So I'm going to just, every time I click, it should generate a new image and upload it to S3. So it's got 35 images of my face. Who wouldn't want 35 images of my face? I'm going to label something now new. Now I'm going to drinks. Drink. Okay, and we're going to put a drink. Where's my camera? Right. Oh, it's just the colours. Okay, so now I've uploaded all those different pictures of drinks. Just going to remove some of the ones which are a little bit off center. My remove isn't working, which means I don't care. Who cares? And then markers. We'll do some markers. A different colour marker. So now I've got a load of pictures of markers as well. So I've got some faces, I've got some markers, and I've got some cans. And they are loaded up into my S3 bucket. So now I'll go back to my Jupyter notebook, and I'm just going to say, well, where is my data bucket name? Sorry, what's my data bucket name? Well, I've actually used this in this example before, so it's webcam3s uploader, and that's the S3 bucket name. And what is the name of the data set? All this is doing really is actually it's basically a structure. So it's just looking at, so I've got 3 folders in my S3 bucket, and they've got labeled different names. So if I just run that now, those variables, bucket name and data set, have now got those variables in it. So then I can run the next section. You don't need to worry about, if you see on a SageMaker app thing, when I run it, it turns to like a star. That means it's running. And then it gives me a number, which is the execution number in this document. It's the 123rd time I've ran something in this document. So that's ran now. I'm just going to go ahead, before I explain what these things are doing, I'm just going to run them all. Run that one, and then after that one, run that one, then run that one, then run that one, then run that one. Run that one, and then run that one. So, what this piece of code does, this document does, it goes and pulls all those images from S3. So this is just Python code, by the way, in my document. So it's literally running it as if I was running it in Bash on the command line. So AWS is the AWS client, S3, synchronize that bucket name with a local folder. So it's just going to basically store it on the Jupyter Notebook instance that I'm running. And then it's going to create those lists of files into structures that the actual container, which is going to run the algorithm, understands. Again, it's not really important what it's doing, but I end up with some classifications. I've got a drinks classification, a face classification, and a market classification. So now I've got it in the right kind of lists that are required by the container. And then I create a training path and a validation path. In machine learning, you can't just use all the images, because it needs to, what traditionally we would use, you use 70% of your images to do training, so train on 70% of the images, and then the other 30% we use that for validation. We have those labels, so we know they are drinks, markers, or faces. So we'll generate a model based upon 70% of the data, and then we'll use the other 30% of the data which hasn't seen or hasn't been trained on, to figure out, is it accurate? And basically it will keep running until the accuracy is good enough that it can recognize the 30% of the images based upon the other 70% that's trained. Does that make sense? So that's how machine learning roughly works. If we used 100% of the data, it would be really accurate at recognizing those exact pictures. But if I was to present it with a new image of a marker, which you've never seen before, it might not be very good at recognizing that, even though it's really good at recognizing the marker in all the other images. In machine learning, they call that overfit, where you've developed an algorithm which is overfitting, which fits perfectly the training data, but actually new data it can't actually read from. So we use validation as a way of kind of validating that it's good. I then create the data. I end up having a variable which has got my trained data and a variable which has got my validation data in there. This stuff's not too important, and I just package it up into the sort of scenario which I need to then go and pass into my classifier. So here's where I first use the SageMaker classifier. I'm using an algorithm called effectively it's a container called estimator. And I'm saying how many instances it should use for the training. So you use one instance of, and this is an EC2 type, which is MLP3X2X large. So for the training, it's going to use that instance type. It's not going to use the machine that this is running on. It's going to spin up a new machine with a GPU on it, and it's going to run that. If I had a really big ML job here, I could say I want 15 of these big GPU beefy machines to run my model and do all of the training data on it. So I create an image classifier basically using the SageMaker API. It's going to create all of the infrastructure to do the training that I need. Then I set up some things called hyperparameters. Hyperparameters is a fancy name for metadata, really, or parameters. I don't know why necessarily they're hyperparameters. Maybe they've had too many Orange Smarties. But it's just like a terminology. It's just like, they're just parameters that we're going to be using. And you can change some of these parameters to affect the model. Some of the model information is just like, what's the size of the images that we're inputting? So we're putting a 224 by 224 image, so explaining what the shape of the image that we're putting into the model. And then some of the parameters, again, I'm not going to go into what these mean, but they are parameters that you could adjust to change, basically to tweak the knobs of how the model works. So you could train it by, you can alter these hyperparameters and basically get a slightly different output from the model. And it's a data scientist's job or a model developer's job to get these just right so that we have the most effective model. Once we've created an image classifier and we've set our hyperparameters, we can then start doing our training. So I run this piece of Python code. It takes all of the information we created before, the data, it runs it through a classifier, and it runs the job, and it runs all down here. Hopefully, is that the one, 8 o'clock? Yeah, that would have been now. And at the end, it should say that it's run. I was expecting a little bit saying it's done, but oh, it's still running, that's why. And then the last piece, what it does is it takes that classifier and it deploys it to an API. So deployed endpoint, image classifier.deploy, tell it how many instances I want. Now, this doesn't have to be a very beefy machine because it's got the model built, it's done all the training, it's just serving, it's like a website, web server really. It's going to deploy that model to an endpoint. Ultimately, I'm going to get a URL that I can call and test. So uploading, generating training model, deploying the model to an endpoint may take a few minutes. We'll come back to that. We'll come back to that. I'm having all sorts of... Right, there we go. So SageMaker's had lots of different enhancements. SageMaker specifically has had loads of different things being added to it to support our customer requirements. GDPR, for example, automatic model tuning, so model tuning some of those hyperparameters automatically. It's able to do some of these things like that. We're constantly evolving this based upon feedback. We also have some other projects, which I'll just talk about briefly. If anyone goes to the AWS Summit in London this year, you'll see this thing called AWS Deep Racer. Get involved if you're doing it. It's slightly different to what SageMaker is doing. It's actually called reinforcement learning. So it's a different kind of learning than what I've been showing you before. But it's a way of, what we do is we've built this autonomous race car. You can program it using SageMaker, reinforcement learning for SageMaker, and then you can race it. And we've basically got a league going. Anyone which comes to the summit can join this, program their own reinforcement model, and then race against other programmed cars, and the fastest car wins. And it's a global event, and basically there's huge prizes for anyone which actually wins one of these things. So we've already done it at reInvent, and there was winners of that. They've gone into a league, and then we're having competitions now. Every summit, ultimately we're going to have a grand finale, probably reInvent next year, where you'll be able to, the winners will all be on stage racing these cars using reinforcement learning. So these are purpose-built cars we've created purely for the purpose of showing how reinforcement learning works. And I won't talk about any of the specifics because it's interesting, but it's another deep thing, and I haven't got much time. But we're going to set up this whole Deep Racer League. If you're interested at all, come and have a look at it at any of our summits. I've labelled some data there. I took my image of my face, my markers, and blah, 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 and classified them. Like, I labelled them effectively. And you need that labelled data to build any kind of machine learning model. But if you're in a situation where you maybe have loads of images or loads of video data and you need humans to go and actually look through that and classify it, we have a service called Amazon SageMaker Ground Truth. We have automated labeling, which we can do for you. And if you require labeling of images or data sets, we also can do that too. We have a service called Mechanical Turk. I don't know if anyone's heard of it before. It's basically a body of humans, real humans, which we can put to tasks. And so basically behind the scenes, behind Ground Truth, there is a fleet of people who will be able to classify images. So maybe you can give them a bunch of images and say, I would like you to classify all of these to be either drinks, faces, or markers. Models being deployed. It's finished training, models available for me on S3, Office Crap. So if I now just run this endpoint, what it'll do is takes that model and generates an endpoint for me. So if I go to SageMaker and just pull out here and go into endpoints, I've got an endpoint called Office Crap. That's a good start. So if I take Office Crap, I'm just going to run another application that I've got. Control C. Actually, can't remember what it's called. SageMaker environments, and then I built this one. Okay, it's going to load up another React application. We should do. And I paste in the endpoint API, and I put in, what was it, face, drink, marker. And it needs to be in alphabetical order for this to work properly, because it's not, it's minimal coding. In any language, pretty much, or in fact, any language that you want, we have native support for a number of different languages including Python, Node, Go, and .NET. And then we have support for, and Java of course, and then we have support for any language which can basically run on Linux. And we can do that by, you can bring your own runtime layer. So we have support for things like PHP. We have support for, through that runtime layer, we have support for things like .NET Core 3. Currently the supported version is .NET Core 2.1, because we only run or allow you to support the latest sort of general availability version of .NET Core supported, but you could run .NET Core using one of these bring your own runtimes. What happens is an event is there's a source, something that happens in your infrastructure. It runs a function, and then that function can do some compute. It can connect to any of the services in AWS or any services anywhere on the planet, and then it does something. This does some black box magic. It can do anything inside of a function. The idea being that an event comes in, the function runs, and you pay as a developer for the time it's running effectively. You don't pay for any time when you're not using it. So if you've got a website, for example, which you built using serverless, and only one person visits that website, then you will only ever pay for that one invocation of that function. If thousands of people visit that website, you'll pay for the thousands of invocations. But any time the site's idle, you're not paying for that function. So it's really useful especially for projects where you're building. You don't really know what the scale of that project's going to be like. You need it to scale if it needs to scale, but you're not quite sure what the scalability requirements are going to be. And also, equally, you don't want to pay for it if it's not being used. Serverless works really well in those sorts of scenarios. So events can be anything. They could be someone requesting an API. In AWS world, that comes through API gateway and then triggers a Lambda. It could be someone adding an object to an S3 bucket. So if I uploaded a photo to an S3 bucket, you can have a Lambda which looks at that photo and classifies and labels it, for example, and then adds metadata to that S3 bucket. That's what the thing does. You could have any notification on things being added to a queue. Any service like DynamoDB records being added to DynamoDB, could be an event source for a function to do something. You could have it running on a timer every 15 minutes to run your Lambda function. There's lots and lots of ways of invoking these functions or starting them up. Effectively, it's a function. So you have a function, and the different languages will have different ways of constructing the file, but this is what it might look like in Python. You have a Lambda handler, and an event which comes in, an event object, which is the data set during the Lambda function invocation, and then the context, which is the context available, like what the request name was, and some of the context around the execution of the function, which you might want to use. For example, if this is S3 offending this, you're going to get information in those two parameters about the file that was uploaded to S3. Like, how do you get that file? How do we? What file was it? Where is it located? What invoked this function? So, a file's added. It invokes this function. Inside the function, you can see which file was actually invoking this function, and then you could read that file, analyze it, pass back the metadata. Bob's your uncle. That's kind of what it does. So, if we want to create a function, this is how we do it inside of, say, Visual Studio. We go to File, New. This is, by the way, I've got the SDK for Amazon installed into Visual Studio. Gives me an infrastructure overview of all my AWS stuff. I can create a new AWS Lambda. I'll say an AWS Lambda project in .NET Core. Press OK. And what it's going to do is going to create give me a blueprint I can select. I'm just going to choose an empty function. And it's going to create a function for me. And the basic one just does a two-upper on a string. So it basically capitalizes everything on that string. So somewhere down here on the function handler, I've got the context and the input that come in, and I've got a two-upper, which basically would capitalize it. So this is going to be a service which gives the answer to every possible problem. And if you're a Hitchhikers fan, you'll know that the answer is always 42. So I've got a very helpful API which basically always returns 42, whatever question is asked. I can save that or run it in this thing called the mock Lambda test tool. Mock Lambda test tool is effectively a tool we've written for .NET specifically, which allows you to test Lambda functions locally. So if you're on a plane and you can't deploy to AWS, you can test your function locally and make sure that the inputs and outputs of that function are correct. So if I give a function input of what's the meaning of life, question mark, and I execute that function, then the response is going to be, of course, the correct answer, 42. And if so now I've got that like running locally. Oops. I might want to deploy that function to actually AWS and get some business value from this API. So what I do inside of Visual Studio is go right-click to the Lambda, publish to AWS Lambda, and then it gives me some information. What account do I want to use? Where do I want to deploy it to? Deploy this one to Oregon. I'm going to give the name a function called answer42. I'm going to say the framework that I'm going to use is .NET Core 2.1. I'm going to press next. And it's going to ask me some information about security, the context of security. I won't go into IAM security in this talk, but basically how that function is able to access other systems inside of AWS. I'm going to upload that file. What's doing there really is it's uploading or packaging up a zip file, which contains your payload. This doesn't have to be done from inside of Visual Studio. It could be done from any CI/CD tool. It could be done from our CI/CD tool called Code Deploy. But ultimately, it uploads a zip file to Lambda. Lambda stores it, and then you're good to go and execute it. From Visual Studio, I can then invoke that function live on the internet. So I can ask the same questions from within Visual Studio. What is the meaning of life? And I could invoke that. And it will invoke it directly, that function, and just give me the information about it. So it started then, it ended then, and the duration of that function was 36 milliseconds. I'll be billed for 100 milliseconds of execution time. We round up to the nearest 100 milliseconds. So if you, so it's important to you want to try and get all your functions running in 100 milliseconds, so you get the most efficiency out of that. But we build 100 milliseconds, so I'm paying 0.32 milliseconds I'm paying probably, that doesn't even round up to a penny in terms of execution, of course. So, and it's telling me the memory size of that execution. 256 megabytes was the memory it took to invoke that. Okay. So if I wanted to do it obviously in different languages, I could do that. I can do it from the console as well. I could do it from the command line. But let's just create a function in Node. And on the AWS Lambda dashboard, we'll go create new function. You can author one from scratch, use a blueprint, or deploy a whole service application. I'm going to use a blueprint, and I'm going to choose one of the Hello World versions. You could use Go, Python, I'm going to use Node. I'm going to configure that. What that's going to do is create me a little bit of code, function code, which is for Node. It's going to ask me for stuff like the name that I want to give this, the function name. Again, the IAM or security role, it's not so important at the moment, but you'll need to know that stuff later. And then this is the actual business logic inside the function. What it does is it takes in a JSON file being passed into it. It logs all of the values, and then it returns whatever the value is in the key one of that JSON input. So now I have my function, and this is what the dashboard looks for these lambdas. This would be exactly what it looks like in C# as well if I went to the dashboard. And it shows me the code. I can actually edit the code directly on here if I want to. If I directly edit it and save it, it will immediately be available, that new version. I don't recommend that you do that, by the way. We can test it from this thing, so we can test it, and basically we pass in this value, we press create as a sort of sample payload. We press create on that sample payload, and then from the top I can just test this function with that payload. It will execute my function and return the results in the console. So value 1's been returned because it's whatever was in key 1 of the JSON. And it's logged all of the different values in the log for that function as well. And again, there's the duration and build stuff. Okay, so there's the key 1 that was returning in the actual code in that function. So that's a really simple function. It's being invoked. Directly from the console. But you might want to direct it from, most people want to actually execute these from an API. They want to execute something. So to do that in AWS, you have to add a gateway, an API gateway at the front of it. So we're going to add an API gateway to this. So go to the AWS Management Console and say, I want a Lambda. So we're going to add a gateway to answer 42, that function which we just added up there. So what you'll see here is this is the design. It shows all the triggers that can event this function, or invoke this function, and all the different settings for it as well. I can put in like different secrets. I can say how much memory the function's allowed to use. I can say how the debugging is going to work. But what I want to say is I'm going to add a new trigger, API gateway. So when someone goes to a URL, effectively, it's going to invoke this answer 42 Lambda. So the configuration is required. We have to set up a new gateway. I could use an existing gateway, or I'm going to create a new one. So create a new one. I don't really require any API keys or any authentication. It's just an open API. And I've basically accepted all the defaults. Press add. That's going to create me an API which I can then call, and it will invoke the Lambda. Now, when I run this, what's going to happen is I'm going to get an error. And the reason I'm getting an error is because API Gateway is doing something for me which I've not handled in my code. I'm just expecting a plain old string input coming in. What this now does is it slightly changes the payload that comes in. You get information about the URL which is invoked, the stuff. So it's an object is changed slightly. Now to fix this, I'm not going to do much. I'm just going to say, okay, well let me test the Lambda first. So to test the Lambda, I'm going to do exactly what I did before in the console. I'm just going to test it directly from here. So just check that answer 42 works, just to make sure. So if I pass in, my Lambda just doesn't expect JSON, it just expects a string. So if I pass in 40, what's it all about? Alfie, that's what I said, isn't it? If I pass in that string to the function directly, not through an API, then that will run. So if I test that, the response should come back 42. And it succeeded, and if I look at the logs, I can see, yes, 42 is the response which I expected to come back. So the problem is with this gateway, well, I can change the way that the Lambda and the gateway work and they integrate. And you can do all sorts of changes to this API in API Gateway. There's tons of things that you can add. You can change the way it responds, what it executes, which Lambdas it executes. You can change the routes all the things the API gateway can manage, you could do there. You could add SSL, all the sort of things you would expect from an API management system. And ultimately, it takes the input and it integrates it into a Lambda. It proxies it to a Lambda function. And it's in this integration request that we want to make an adjustment. We want to say, don't do anything with it. Don't tell me anything about the incoming request. Don't do any fancy things. Just literally proxy all the data which comes in. So I can then go to this method execution, go to the integration request, and go into here and just switch off, use Lambda proxy integration, switch that off. I don't want it to do any fancy things with Lambda proxy integration, and I'll take that, untick it, and then deploy that. And now, when I execute that URL, inside Postman, or if I just call it, what's the meaning of it all? I push it over to that API. Now it just passes the string in directly. It doesn't do any coding or JSON coding, and it just gives me the response I expect, which is number 42. So that's how you would get a very sort of straight-through API gateway working in Lambda. So we've had lots of releases in Lambda. We were the first people to launch a serverless product in 2015. We had very basic support of a couple of languages. You could get other languages working through HAP, but it wasn't until 2016, which I got really interested when they actually added C# support. I do a lot of Node, but I actually prefer C# personally. So I started looking into it around 2016, and you'll see that the .NET stuff is really improved over time. We have now .NET 2.1 support. We also have support for PowerShell natively as well, if that interests you at all. But we have loads of things that we're adding all the time to our serverless framework. And it's basically, serverless has gone from this thing where you used to do simple APIs and stuff to now building full-blown applications. There's a concept called Lambda Layers. So we build a simple Lambda function there where we're zipping our file up and we're uploading it. If we've got any dependencies with that function, we have to include those in that deployment package, that zip file. Well, sometimes the dependencies can be quite large and difficult to pass around. You don't want to have to upload them every single time. So what you can do is create a layer, and you can have up to 5 layers in a Lambda function, and those basically contain, those layers can contain like shared information. It's particularly useful in like dynamic runtimes, where you could like literally have functions or dynamic libraries loading in. In C# you might use it to cache things like NuGet packages in your application. And we also use this to actually add new runtime layers as well, which is a slightly different version of it. But what it means is that we can basically have common runtime information like libraries and dependencies in these layers, and then our actual function code stays really svelte. And so we're only uploading that small function, and the layer we're actually sharing across a number of functions. So it's a way of sharing information across functions. Each layer, when you publish a layer, you get a resource URL to that resource, which you can then call from any other function. So you can add a layer up to 5 to any function. And we can also add runtimes. So we have runtimes for lots of languages which aren't natively supported, like the .NET 3 is not natively supported, but we've added it through one of these layer runtimes. And we also have support for crazy languages, like we have COBOL support in Lambda if you want to do that. I'm writing one for VBA, and yeah, some interesting languages being added. Just yesterday we added support, this was only yesterday we added support for .NET Core 3, using that exact system of adding or bring our own runtime. It's quite a cool feature. Serverless applications, they're used for all kinds of things, but I tend to use them, you can use them for like backends, for data processing on a schedule, chatbots, automation of things, Amazon Alexa, web applications, static website hosting. I can even host an entire .NET application, and this is something we've built in now to the samples for Visual Studio. So if I go into Visual Studio and I say File, New, Project, and I say an AWS Serverless application. Now it's different from a Lambda project because it includes not just the functions, but also the API gateway and all the other stuff in it as well. So we can describe in one file the entire infrastructure for our function system. I've got a .NET Core website. It's got a Lambda entry point, which is what Lambda is going to enter this application with. And there's some middleware there to execute the website. And then I've got a local entry point, which is what I'll use when I'm locally testing this outside of Lambda. And this is basically a .NET Core website with a startup.cs file, And in the serverless template file, it describes what the API gateway for this application should look like, and it describes things like what the URL should look like, how it should proxy over the requests which come into the function into .NET. We describe that all in that file, then I can right-click that, deploy it, maybe if I can go publish to AWS Lambda, and then I'm just going to fast forward this. I give it a few sort of information and details. It will create all of the infrastructure required to run this. This is like the functions, the API gateway, and once it's ready, it's going to produce a URL for that function for me, because it's created the gateway for me. I click on that to run that. So these are the common sort of scenarios for serverless architectures. You have an S3 bucket, an object's put to an S3 bucket, it executes a Lambda. You have data coming off a topic, it might be from a queue or some system, it invokes a Lambda. You have a message coming in from a queue, and it, maybe it runs on like a service like SQS, and then it runs into Lambda. And you can have, the way that these serverless architectures work is that you can have very straightforward things like objects being added to buckets to really complicated messaging and how we invokes things and retries for, you know, if it fails to invoke or there's a problem or an error, how can we retry it? We have a concept of queuing or dead letter queues which queue up jobs which didn't work or whatnot. I was going to talk about a product that I've built using serverless, but I've kind of sort of run out of time. So what I'll do instead, I'll just show you that one GIF. Anyway.
It's not a data warehouse.
No, I don't think it is. It's basically, it was a little project that I worked on to split audio files. And what's interesting about it, I'm not a Python developer, but this was a much easier problem to solve in Python. And this is one of the reasons why serverless is really valuable. I'm a .NET dev. If I want to split audio files by silence, I want to find silence in a file, it was really hard to do that with C#, or I'd have to buy a license for a product, a commercial license, which is about £3,000 per seat. So I looked around and found that in Python they had a library which did exactly what I want to do. And this is the kind of benefit of something like Lambda, is that I don't have to write everything in C# anymore, or Node, or Python. But I can choose the best language to solve that particular problem. And in this particular problem, Python was definitely the easiest way to solve this problem. And so I wrote, God forbid, some Python, which did the exact thing that I wanted to do, which is take some audio files and split them at certain points in that audio file based upon silence in the audio file, for a particular business reason that I won't go into explaining. And then when someone uploads the audio file into an S3 bucket, it kicks off that Python function, it splits the file into multiple files, and then builds into my workflow. It kind of shows the power of serverless, that we can be polyglots in our system. We don't have to choose one language and stick to it. We can break down into microservices and maybe use the right language for the right job. So when you start building not just simple orchestrations where you've got one event and there's one function. Maybe you've got one event which causes a function which then has a chain of functions which cause another function. And you end up with this orchestration of functions. We have a system called step functions which control the orchestrations of multiple functions. And it's basically like a graph that you can control the workflow of these different functions. Again, we're out of time, so I'm not going to go into exactly what it is. The last thing I want to explain is the concept of an AWS serverless application model. You'll see this it's a great way to learn serverless actually. Anyone can build a serverless application and then publish it to our serverless repository for applications, and then anyone can deploy that as well. So they produced this thing called a SAM template. You saw that earlier in that website demonstration. It shows the different serverless functions and the different API gateways and all the infrastructure. And then that one file, it's basically like Terraform or CloudFormation. I don't know if you're familiar with any of those terminologies. It's just a descriptor which describes all of the infrastructure for that particular that service. You create these SAM templates, you deploy them, and then you can either just deploy them yourself with your CI/CD pipeline or whatever, but you can also do this, which is publish them as well in this open way. Basically, you publish them to GitHub, and then there's a way of hooking them into our repository, which means that anyone can then deploy the applications that you might have built. And so there's one which I really liked, which I saw literally today. If I go into here, called Serverless Survey, and basically it's a survey system written for serverless. So basically if you want to ask some people some questions and get some responses. To do that, you're going to need a function which collects the responses. You're going to need a database to store the information in. Well, you can deploy a survey system by just clicking that deploy button. It runs through that template file, it builds the infrastructure in your account. You have to set up you have to provide some information if you want to deploy it, like the name of the stack and various other bits and pieces, but ultimately this will then deploy all the serverless aspects of that system to your account. I'm not going to have time to do this, but it will eventually, you will be able to build like a little serverless survey system for you to use. There's a few other things that I want to show you, which I'm definitely going to run out of time. I've run out of time to show you. But I wanted to sort of explain a little bit, and if you're interested at all, if you follow me on Twitter, I'm @thebeebs on Twitter. I've got demos of this coming out shortly, and I'll also be demonstrating this at the summit in London, which we have coming up, of building chat applications or real-time applications using serverless. So traditionally, I'll quickly show you the system which I wrote in a thing called SignalR. If I go to this, I don't know if anyone's got their phone on, but if you point it at that QR code, it might not be big enough in this room actually. Do I even have my phone? No, I don't. Hopefully there'll be like 2 people on that. You don't have a phone. If you put the camera up to that phone, does it work at all? Yeah. Literally one person. You're on a website that says please wait. Cool. Now, if I click next, it should now, anyone who's got the please wait system should now see, oh gosh, I think someone was using this today. We've got a little bit of a logic error there maybe. So people, hold on, I don't know why it's doing that. People voting for either coffee or beer. I'm not sure I trust this room, but more people are voting for coffee apparently than beer, but I don't trust those numbers because they keep changing. Let's try another question. Tabs versus spaces. I don't know why my logic is screwed up. I apologise for that. I can understand why it would go wrong once, but I can't understand why it would go. The idea is it's a real-time voting system. I wrote it in SignalR. It's actually deployed on Elastic Beanstalk. It's not serverless at the moment. Maybe that's how I solve this problem. But it's using WebSockets. Now, the problem with building a real-time application is that to create WebSocket applications, you need servers which are literally listening to create a WebSocket connection between the client and the server. And it's been something which you've not been able to do very easily in serverless applications because serverless effectively are only running for the time of the function. They're not running for long periods of time. So we've added a new feature to API Gateway, that other technology I told you, which sort of sits in front of Lambda. And API Gateway, what it will do is you can set one up to support WebSockets, and then API Gateway will manage the WebSocket communications, and then when requests come in over the WebSocket, it executes Lambda functions. And so you're able to build real-time applications like this, but with serverless technologies now. And a few years ago, when we were looking at serverless, you were only really able to build a certain type of application. If you want a function and an API on an endpoint, you could build that with serverless. Now we're getting to the world where you can build full-blown websites with serverless, with different routes and so forth. Now we're getting to the point where you can build real-time applications with serverless. It's getting to the point now that you can build any style of application using serverless and architect it using serverless technologies. You don't have to manage the servers, you don't have to create the servers, you don't have to pay for when the servers end up staying idle. So it's a really interesting new way of building applications, and it's gone from just being this sort of way of running a couple of APIs to now being able to run lots of different style applications, including real-time applications. I do a workshop on how to build real-time applications in SignalR, and also in using this new API Gateway WebSockets feature as well. So before I go, I'm just going to quickly just go back to one thing. Right, let's see if that SageMaker deployed. So it's in service, which is good. I'm just going to rerun this application. Drink face marker. I'm going to paste that. Drink face marker. We're going to classify this. Come on. Face! 90% sure that's a face. Classify marker. Marker. Marker, marker. And then for my finale. I'm not going to get my face in it, that would be a mistake. Oh, shh. Oh, damn. Damn you. It's very close. It's 0.4% thinks it's a drink and 0.4% thinks it's a marker. Maybe it's picking up my face. And if you look at the actual images on the training data, you might be able to see why it's easier to classify one than it is the other. You'll see that my hand is in all of those pictures. And what I'm probably doing there is classifying the hand. So, bugger.
Can you have two objects in the same image?
Well, yes, you could. My model's really dumb, right? So I'm just classifying 3 things with very small amounts of data. You could absolutely get more complex with these things and find multiple images. My model doesn't do that. Our model for recognition is being trained in a similar way to this, albeit like not on stage and in 5 minutes. And that's able to, that will be able to recognize multiple objects in an image and so forth. So yeah, you can absolutely do that with machine learning, but that's not what this one does. The way that it does that actually is multi-pass often. So it multi-passes the same object, does it in parallel, and finds multiple objects in certain things. I'm really annoyed. I should have just stuck with 2, shouldn't I? And then you'd have all been like, oh yeah, it works. Come on. Drink! If I get my hand out of it, it thinks it's a drink. It's the hand which is confusing it. I'll know that for next time. So, that was a massive whirlwind. I kind of totally run out of time. But I've tried to show you there, machine learning in a nutshell, all the different services and AI that you can use. I've showed you SageMaker, if you want to build your own models and custom models, and you can make them far more complex than the one that I've built today. And then I showed you serverless. And serverless is a way of building applications, which means that you only pay for the compute that you actually physically use. They're highly scalable. You can create all types of application, from websites to APIs to real-time applications. And thank you very much for listening. If anyone's interested in following me on Twitter, which I recommend highly that you do, it's @thebeams. Does anyone want to say anything, or are you good? No.
Oh, yeah.
Right, so thank you for coming. Our next talk will be about Docker and storage OS, and that will be in roughly 4 weeks' time. I'll put the date on the website. So, thank you.
To run that. So these are the common sort of scenarios for serverless architectures. You have an S3 bucket, an object's put to an S3 bucket, it executes a Lambda. You have data coming off a topic, it might be from a queue or some system, it invokes a Lambda. You have a message coming in from a queue, and maybe it runs on like a service like SQS, and then it runs into Lambda. And you can have the way that these serverless architectures work is that you can have very straightforward things like objects being added to buckets, to really complicated messaging and how we invokes things and retries for, if it fails to invoke or there's a problem or an error, how can we retry it? We have a concept of queuing or dead letter queues which queue up jobs which didn't work or whatnot. I was going to talk about a product that I've built using serverless, but I've kind of sort of run out of time. So what I'll do instead, I'll just show you that one GIF. Anyway.
It's not Sage's warehouse.
No, I don't think it is. It's basically, it was a little project that I worked on to split audio files. And what's interesting about it, I'm not a Python developer, but this was a much easier problem to solve in Python. And this is one of the reasons why serverless is really valuable. I'm a .NET dev. If I want to split audio files by silence, I want to find silence in a file, it was really hard to do that with C#, or I have to buy a license for a product, a commercial license, which is about £3,000 plus C. So I looked around and found that in Python they had a library which did exactly what I wanted to do. And this is the kind of benefit of something like Lambda, is that I don't have to write everything in C# anymore, or Node, or Python. But I can choose the best language to solve that particular problem. And in this particular problem, Python was definitely the easiest way to solve this problem. And so I wrote, God forbid, some Python, which did the exact thing that I wanted to do, which is take some audio files and split them at certain points in that audio file based upon silence in the audio file, for a particular business reason that I won't go into explaining. And then when someone uploads the audio file into an S3 bucket, it kicks off that Python function, it splits the file into multiple files, and then builds into my workflow. It kind of shows the power of serverless, that we can be polyglots in our system. We don't have to choose one language and stick to it. We can break down into microservices and maybe use the right language for the right job. So when you start building not just simple orchestrations where you've got one event and there's one function. Maybe you've got one event which causes a function which then has a chain of functions which cause another function. And you end up with this orchestration of functions. We have a system called step functions which control the orchestrations of multiple functions. And it's basically like a graph that you can control the workflow of these different functions. Again, we're out of time, so I'm not going to go into exactly what it is. The last thing I want to explain is the concept of an AWS serverless application model. You'll see this it's a great way to learn serverless actually. Anyone can build a serverless application and then publish it to our serverless repository for applications, and then anyone can deploy that as well. So they produced this thing called a SAM template. You saw that earlier in that website demonstration. It shows the different serverless functions and the different API gateways and all the infrastructure. And then that one file, it's basically like Terraform or CloudFormation. I don't know if you're familiar with any of those terminologies. It's just a descriptor which describes all of the infrastructure for that particular that service. You create these SAM templates, you deploy them, and then you can either just deploy them yourself with your CI/CD pipeline or whatever, but you can also do this, which is publish them as well in this open way. Basically, you publish them to GitHub, and then there's a way of hooking them into our repository, which means that anyone can then deploy the applications that you might have built. And so there's one which I really liked, which I saw literally today. If I go into here, called Serverless Survey. And basically it's a survey system written for serverless. So basically if you want to ask some people some questions and get some responses. To do that, you're going to need a function which collects the responses. You're going to need a database to store the information in. Well, you can deploy a survey system by just clicking that deploy button. It runs through that template file, it builds the infrastructure in your account. You have to set up you have to provide some information if you want to deploy it, like the name of the stack and various other bits and pieces. But ultimately, this will then deploy all the serverless aspects of that system to your account. I'm not going to have time to do this, but it will eventually, you will be able to build like a little serverless survey system for you to use. There's a few other things that I want to show you, which I'm definitely going to run out of time. I've run out of time to be able to show you. But I wanted to just sort of explain a little bit, and if you're interested at all, if you follow me on Twitter, I'm @thebeebs on Twitter. I've got demos of this coming out shortly, and I'll also be demonstrating this at the summit in London, which we have coming up, of building chat applications or real-time applications using serverless. So traditionally, I'll quickly show you the system which I wrote in a thing called SignalR. If I go to this, I don't know if anyone's got their phone on, but if you point it at that QR code, it might not be big enough in this room actually. Do I even have my phone? No, I don't. Hopefully I'll be able to people on that. You don't have a phone there. If you could put the camera app to that phone, does it work at all? Just literally one person. You're on a website that says, please wait. Cool. Now, if I click next, it should now, anyone who's got the please wait system should now see, oh gosh, I think someone was using this today. We've got a little bit of a logic error there maybe. So people, hold on, I don't know why it's doing that. People voting for either coffee or beer. I'm not sure I trust this room, but more people are voting for coffee apparently than beer, but I don't trust those numbers because they keep changing. Let's try another question. Tabs versus spaces. I don't know why my logic is screwed up. I apologise for that. I can understand why it would go wrong once, but I can't understand why it would go. The idea is it's a real-time voting system. I wrote it in SignalR. It's actually deployed on Elastic Beanstalk. It's not serverless at the moment. Maybe that's how I solve this problem. But it's using WebSockets. Now, the problem with building a real-time application is that to create WebSocket applications, you need servers which are literally listening to create a WebSocket connection between the client and the server. And it's been something which you've not been able to do very easily in serverless applications because serverless effectively only running for the time of the function. They're not running for long periods of time. So we've added a new feature to API Gateway, that other technology I told you, which sort of sits in front of Lambda. And API Gateway, what it will do is you can set one up to support WebSockets, and then API Gateway will manage the WebSocket communications, and then when requests come in over the WebSocket, it executes Lambda functions. And so you're able to build real-time applications like this, but with serverless technologies now. And a few years ago, when we were looking at serverless, you were only really to be a certain type of application. If you want a function and an API on an endpoint, you could build that with serverless. Now we're getting to the world where you can build full-blown websites with serverless, with different routes and so forth. Now we're getting to the point where you can build real-time applications with serverless. It's getting to the point now that you can build any style of application using serverless and architect it using serverless technologies. You don't have to manage the servers, you don't have to create the servers, you don't have to pay for when the servers end up staying idle. So it's a really interesting new way of building applications, and it's gone from just being this sort of way of running a couple of APIs to now being able to run lots of different style applications, including real-time applications. I do a workshop on how to build real-time applications in SignalR, and also in using this new API Gateway WebSockets feature as well. So before I go, I'm just going to quickly just go back to one thing. Right, let's see if there's SageMaker deployed. So it's in service, which is good. I'm just going to rerun this application. Drink face marker. I'm going to paste that. Drink face marker. I'm going to classify this. Come on. Face! 90% sure that's a face. Classify marker. Marker. Marker, marker. And then for my finale. I'm not going to get my face in it, that would be a mistake. Oh, shh. Oh, damn. Damn you. It's very close. It's 0.4% thinks it's a drink and 0.4% thinks it's a marker. Yeah, maybe it's picking up my face. And if you look at the actual images on the training data, you might be able to see why it's easier to classify one than it is the other. You'll see that my hand is in all of those pictures. And what I'm probably doing there is classifying the hand. So, bugger.
Can you have two objects in the same image?
Well, yes, you could. My model's really dumb, right? So I'm just classifying three things with very small amounts of data. You could absolutely get more complex with these things and find multiple images. My model doesn't do that. Our model for recognition is being trained in a similar way to this, albeit like not on stage and in 5 minutes. And that's able to, that will be able to recognize multiple objects in an image and so forth. So yeah, you can absolutely do that with machine learning, but that's not what this one does. The way that it does that actually is multi-pass often. So it multi-passes the same object, does it in parallel, and finds multiple objects in certain things. I'm really annoyed. I should have just stuck with two, shouldn't I? And then you'd have all been like, oh yeah, it worked. Come on. If I get my hand out of it, it thinks it's a drink. It's the hand which is confusing it. I'll know that for next time. So, that was a massive whirlwind. I kind of totally ran out of time. But I've tried to show you there, machine learning in a nutshell, all the different services and AI that you can use. I've showed you SageMaker if you want to build your own models and custom models, and you can make them far more complex than the one that I've built today. And then I showed you serverless. And serverless is a way of building applications, which means that you only pay for the compute that you actually physically use. They're highly scalable. You can create all types of application, from websites to APIs to real-time applications. And thank you very much for listening. If anyone's interested in following me on Twitter, which I recommend highly that you do, it's @thebeeps. Does anyone want to say anything, or are you good? No.
Oh, hold together.
Right, so thank you for coming. Our next talk will be about Docker and storage OS, and that will be in roughly 4 weeks' time. I'll put the date on the website. So, thank you.